Hi, I'm Steve Higgins. I'm the Director of Animal and Environmental Compliance for the University of Kentucky College of Agriculture, Food, and the Environment. Today, we're going to talk about all-weather surfaces. This presentation is designed for cattle, but it has applications to horses and other livestock enterprises. But most of the data is actually geared towards cattle. So what I want you to look at is if you have an animal that's standing in 4 to 8 inches worth of mud, its feed intake goes down on average by 12%. Well, why does the feed intake go down? Well, that's because the animal is actually walking in mud. There's a lot of drudgery involved there. There's a lot of work that's involved with pulling those hooves out of the mud. So the animal actually doesn't eat as much, okay? But its total feed required goes up by 12%. Well, why does it go up? Because it's a lot of drudgery walking around in mud, and if the animal's hair coat is clogged in mud, it requires more feed or more of a maintenance diet to stay warm and keep warm. Therefore, your average daily gains are going down by 14% for 4 to 8 inches worth of mud. This year, which is the 2017-2018, we had a whole lot more than 4 to 8 inches worth of mud. So the thing I look at is if you can actually solve the issue of the 4 to 8 inches worth of mud, then there's two rewards that are gained here. If you can get rid of the mud, the total feed required goes down back to zero from 12%, so that you get 12% gains there. But you also get your 14% daily gains back. So we're looking at an efficiency of about 26-27% here just by getting rid of 4 to 8 inches worth of mud. And some producers say, well, I can't afford to get rid of mud and stuff like that. No, you can't afford not to. This is a 26% hit right off the bat just with mud alone. So the next thing you want to look at is okay, if I want to get rid of the mud, then that becomes an engineering solution. This slide shows basically foot pressures that are applied by different species of animals, different things. So a human being provides about 14 psi or 14 pounds per square inch to the surface of a soil or a flooring or whatever. So 14 psi. Cattle are basically 27 psi, which is essentially twice as much. Humans are on 2 feet, cattle are on 4, so the weight distribution is over 4 feet. But I want you to pay attention to here is a D9 dozer, Caterpillar dozer, is 16 psi, which means that cattle provide 166% more pressure to the surface of the soil than a 50-ton bulldozer. Now, this is standing. So if you actually look at walking, all right, then the pressure or the weight distribution goes from 4 feet to 2 feet for horses. For humans, it goes from 2 to 1. So then you look at that, and then you can see it's 48 psi. So that's the target number that you're looking for. What you want to do is you want to provide what we call an all-weather surface that provides at least 48 psi for these animals to stand on so that they don't sink. Another thing I want to bring up about this is that if you have a mud lot and you go from point A to point B, if you walk slow or if you walk fast, in which situation do you sink deeper? The answer is if you walk slow. If you walk slow, you provide more pressure over a period of time, and therefore you would sink deeper into the mud. The other thing I want to ask is once you get to point B, if you turn around and walk back to point A, okay, if you walk back in the same path, do you sink more? Or if you start a new path, how does that go? Well, about 70 or 80% of the compaction that occurs from walking occurs on the first pass. The second pass does provide additional compaction, but not as much. So then the other thing you want to think about is how do cattle walk? Well, they walk slow and they walk in the same path, which is when you see what I call cow touring, or a path that runs across a field, you can see how deep it is and how worn it is because cattle walk in single file in the same path. This slide is just a visualization of the previous data that I showed you that basically shows this is a 50-ton bulldozer, and it provides 16.1 psi or pounds per square inch to the surface of the soil, whereas again cattle are twice that much or more than that, 3 times that much at 48 psi. Now the issue with the data set that I showed you that showed the PSI of cattle being 48 PSI for an animal that's walking, around 27 for one that's standing, the problem with that data set is it was collected in the 1950s. In the 1950s, we basically raised cattle that were about the size of a St. Bernard, okay? In this slide, it shows Lyndon Johnson standing there with about a 3-year-old bull based on the size of those horns. That is a mature bull. This is not dwarfs, this is not miniatures, this is the genetics that we had at the time. This is the type of genetics that we have today. Okay, we've actually backed off this size in the last couple of years, but we have actually increased the size of animals probably 30 or 40% since the 1950s. Now, what I want you to imagine is what is the compressive forces of the feet of this particular animal here, or its dams. So, in addition to the trampling effect of cattle traffic or foot traffic, livestock traffic, however you want to put it, there's also the tractors or the vehicles that you take into the field. And this can vary from tractors to trucks to ATVs, whatever. Those also have compressive forces. As a general rule of thumb, okay, the pounds per square inch applied by those tires is usually about 1 to 3 psi higher than the tire pressure of that particular vehicle. If you actually put loads on that tractor of roll bales on the front and back, then the axle load actually increases, which means that the pressure might not be, or might be the same, but you're actually having more compressive forces or more compaction on the subsoil. So here's some of the data that we already talked about before, which is the foot pressures of cattle, livestock, and humans, okay? And then what you want to do from an engineering standpoint, knowing that these are your pressures that you're dealing with, what you want to do is you want to develop what we call an all-weather surface, which is designed to support the weight of livestock, traffic, vehicles, so on and so forth, without basically failing. So when you look at this surface type, one of the first ones, or the first one, is basically it says soft clay or sandy loam. Soft clay, or actually sandy loam, is a direct texture characterization of topsoil. Okay, so topsoil cannot support the weight of livestock, particularly when it's wet, which is why we create mud. And so you can see that pressure is 13.8. And again, if you go with the cattle pressures of 48 for a 1950 size cattle, that's not going to work, which is why we have the problem that we have. So what you want to do is you want to go down that list and basically find something that's greater than 48 that'll support the weight of cattle. So the first one I come to is loose gravel or compacted coarse sand at 55.6. Now, what you have to realize is let's say that you had a vacation where you were on the beach, you're walking along the beach and you stop and the surf comes up and it goes past your legs and then recedes back into the ocean. What happens to you? You sink, because when you get these surfaces wet, they lose their strength. Okay, so that's not going to do it. But the next one at 83.3 will, which is compacted sand or a gravel mixture at 83 psi, which is why the NRCS, Natural Resources Conservation Service, CAPE, County Ag Improvement Funds, or the Division of Conservation fund heavy traffic pads, because they are designed to support the weight of cattle without failing. And then you go to other things like soil cement at 2400, you go to concrete at 6000 psi. This is why we place concrete around waters, around feeding areas, or on the backside of feeding bunkers, because essentially if concrete is placed properly, it should last easily 30 years. It's almost indestructible. Now, let's throw in some economics. Okay, so here we have an annual cost comparison, and this is just relative dollars. So let's say we go with the concrete at a $3,750 cost, okay? Now, again, this is relative dollars, but a lot of people don't want to put in concrete because it has a huge upfront cost at around $110 a cubic yard, plus the gravel and the forming that goes with it, okay? But again, if it's placed properly, it's indestructible. It'll last throughout the farming seasons or the life of that farming operation. So, but a lot of producers don't want to go with concrete, so they'll go with something less. Okay, well then you could go with gravel, and so you look at straight gravel is $3,400, which is just a little bit less than the concrete. Well, the reason why it's a little bit less is because the volume of gravel that you need to support the weight of cattle. If you're putting in a gravel pad to support the weight of cattle, it needs to be at least a foot thick, which is a lot of rock, which is why it's so expensive. Now, you can get by with something cheaper, which is in this case $2,400 for geotextile fabric and rock, okay? Now, in this case, you use less rock, but you have to use the filter fabric, and you have to use the right kind of fabric, and it all has to be placed properly. And in that case, you should have something that lasts quite a while. But it's kind of a deferred cost to concrete, because if you scrape that rock aggressively, then you're hauling away rock, which then has to be replaced, and so the cost of using rock pads actually goes up over time, and therefore maybe you should have just gone ahead and just bit the bullet and gotten the concrete pad. Now, the most expensive cost on here of all the options at almost $5,000 is doing nothing. Okay, so that's having hanging tags of mud manure hanging off of animals, them covered. That's where their hair coat is clogged. That's where their maintenance diet increases. Maybe you're looking at higher mortalities. You're looking at being docked for taking those animals to the stockyard and having them covered with mud. There's all kinds of things here. Having to feed more, having more of that feed commingled in with the mud. So this whole issue with mud costs producers money, which is why it needs to be solved. Another way of looking at the cost of mud to a livestock producer is to look at this next slide, which basically shows you that if you have no mud, you can finish an animal out in 114 days at a cost of $6,200 or $6,250 per hundredweight, which again, we're just looking at relative dollars. But if you have an animal that's walking in 6 to 8 inches worth of mud, basically that animal, it takes 133 days to finish that animal, which means it's on your property or on the farm for 3 weeks longer than what it should have been, which means maybe you're losing market gains or whatever, but you're having that animal on the property for 3 more weeks means you have to count it, means you have to check it, means you have to feed it, might mean you have to doctor it, okay? And so this issue of mud means, on this case, you've lost $6,350 for 6 to 8 inches worth of mud. Now, my economic theory is this. If you have lost $6,350 for that amount of mud, what you want to do is that is the amount of money that you should spend on a project to alleviate the mud problem. So you've got $6,350 to spend on alleviating mud and then be done with it. And then you don't have to deal with it year after year after year and continually taking these hits on your production. So now that you know what causes mud and how it contributed to basically foot traffic and vehicle traffic and stuff like that, what I think a producer wants to do or should do is control traffic. Control where the tractor goes. Control where you feed. Control putting in heavy traffic pads so that these animals don't create mud, but you do that in certain points. So what I like to do is create what I call control points, where basically you set up feeding operations so that these animals can't create mud, so you reduce the drudgery on them and you don't take a hit on production. There are probably 3 main things to consider when putting in heavy traffic pads. Location, location, location. Okay, so as far as control points, as far as putting things in, I want to go through a couple concepts. So this slide right here shows a feeding area that's basically at the bottom of a hill, in the bottom of a valley. And so I want you to think about the concept. So all the water from those hillsides is basically running down this valley. So you don't have the water that's hitting on that particular area if you were on a summit position. In the bottom of a valley, you have all the water that's running down those hills, all that's water accumulating, all that water's running through there. And this is where this gentleman chose to put a feeding area. Well, when you add water to soil, you basically get mud. In this situation at the bottom of a valley, you get a whole lot of water, okay? So there's that one. Here's another location that was bad. So you have a stream that's basically dissecting this feeding area. You got feed bunkers on one side, you got hay on the other side, you got cattle crossing over. Again, what this is a whole lot of water, and with that creek running through there, what's happening is the water table in those floodplain soils, which this is where this is located, is actually higher than where it would normally be during a drought year, obviously. So we choose wintertime to feed, and we're feeding in an area that has an accumulation of water when we want less water to deal with. Now, let's look at some data again on the bearing capacities of different types of soils, okay? So you have hard clays with shales, you have stiff clays and sandy soils, and what I want you to look at is the upper and lower PSI, or pounds per square inch. The easiest thing to probably do is just look at the average, okay? So again, we're trying to meet that 48 or more PSI of an all-weather surface. So hard clays and shales, essentially, I mean, that's running around 78. That's very suitable for feeding animals on a hard clay. But when you add water, it's going to get weak. And then you just kind of go down the list. But then when you get down to the lower part of the table, it's talking about soft clays and silts, and very soft clays and silts, being a PSI of around 12 and 4 on average. Well, on these two previous slides that I showed you, when you have erosion, you have deposition of soil, sediment in the bottoms or in the valleys. Typically, that is going to be silt, okay? Silt has no strength for supporting the weight of cattle, especially when it gets wet, okay? And also the depth of that silt, it like goes on forever. It can be 3 or 4 feet or more in some of these valleys, which means there's no bottom, there's no clay to get down to. So feeding in bottoms, okay, where all the water accumulates and where you have a surface material that's consistent of silt, is not a suitable place to develop a control point or an all-weather surface area for feeding cattle, or any other livestock for that matter. So if you're going to install a heavy traffic pad consisting of geotextile fabric and rock, you want to do it on well-drained soils. Bottom areas in valleys are also well-drained soils, or have well-drained soils, but that's not the location you want to use. You want to use summit positions which have well-drained soils. Now, they might start off as well-drained, but once you start feeding cattle on them, they're no longer going to be well-drained. But the concept is that site was suitable for doing a winter feeding area. So when you start off, what you want to do is you want to excavate all the soil out of a pit, okay? Because the soil, topsoil, has no strength to support the weight of cattle. You want to cut down until you get down to a compactable clay layer, which is typically around 9 inches, depending on how much erosion that's occurred on the farm. Now, once you cut straight down, you want to excavate that soil out. You want to have a hard compacted clay layer. Then you put your geotextile fabric in the bottom of that hole, or in the bottom of that pit, kind of like putting in, paper into a cake pan, okay? The fabric does not go on the surface of the grass, does not come out on the surface, because if you hook it or snag it with a bucket, it's going to ruin it, okay? And it's also photosensitive, which means it's going to degrade in light. So you go down, you excavate, you put in the geotextile fabric. You want to put in the proper fabric. Normally I tell people to use non-woven, about an 8-ounce fabric, but now they've come up with really interesting or good fabrics that are actually woven fabrics that are used that actually help infiltrate and separate the soil from the rock, which is good, but you got to make sure you get the right kind of fabric. You don't want to use the woven kind of fabric that they use for silt fences. That's just not going to hold up. That's not going to be suitable enough to as a livestock feeding area. And then, so after you put the fabric down, then you come back with either 2s, 3s, and 4s, a layer of those, put those down, and then you come back with a layer of dense grade aggregate up on top of that. Some people use dense grade aggregate, some used crushed stone base, which is used in a lot of highway projects, but you want to put enough overburden of that dense grade aggregate over top of that larger size aggregate rock so that it doesn't work its way up to the top, or it's getting covered so it's not at the surface, because cattle don't like to walk on 2s, 3s, and 4s. Some producers like to come back after this and put in an inch or 2 of ag lime or class I sand as a top layer onto this. That's a very good idea, because when you go to scrape off these areas, the bucket will slide across that interface of the dense grade aggregate and the class I sand or ag lime very easily, so it scrapes up the manure and the rock very easily. Then when you load it on a manure spreader, take it out into a field and apply it, you're actually applying lime at the same time you're applying manure. So it's a good practice to do. This is a photograph of a heavy traffic pad being placed in, so you can see where we've removed the topsoil. We got a smooth, hard, compacted clay layer right there. You can see the sidewalls of the soil, which is exactly what you want. So what you want to do is you want to create essentially a step, and you use that step to actually hold that rock into place. Okay, the sidewall of that soil is holding that depth of rock in place. If you just went ahead and put fabric on top of the grass and then you put rock on top of that, there's nothing to hold it in place. It's going to get scattered to the 4 winds. Then comes the process or the task of laying down the fabric. In this case, we're laying down the fabric. If you're putting it down on a sloped position, which is good because you can get that drainage, you want that drainage. So you would actually lay the fabric. If you're putting down multiple sheets, you would lay it essentially like shingles. You start at the bottom of the run and you work your way up. That way the water or any kind of accumulation of moisture is going to run across the surface of the fabric and not underneath of it. If the soil in the background is actually wet, because of rain events and stuff like that. You don't want to put the fabric down because it'll never dry and you're going to have a weak base. You want that soil to be dry before you put the fabric down and do this process. We're also pinning this down with grass pins. So we overlap the fabric about 1.5 feet, and then we put a pin about every, 3 or 4 paces. And again, what you want is no wrinkles in this fabric, because if there's wrinkles, it's not going to provide the reinforcement that you need to spread out that hoof load or that tire load over a greater area. In this photograph, we were actually applying the rock on top of the fabric at this point. Now, there's a couple different ways of doing this. One is you just have the dump truck pull in on the edge of the fabric or the edge of the pad and then dump a load, and then you have essentially a bulldozer to basically push that rock out over the fabric. Another way of doing it is to set the chains on the gate, and so you can actually have a good qualified dump truck driver that actually backs out onto the pad as he's applying the rock, and then when he gets done, he pulls off the pad on the same rock that he laid. If you actually have a dump truck pull in on the fabric by itself, dump a load, and then put it in gear to drive off, what's going to happen is those rear axles are going to slip and they're going to wrinkle that fabric and it's going to mess it up. So you either bulldoze that rock on, or you have the truck driver back over the rock as he's applying it. Then you're essentially just spreading it out, but you want to compact that rock as tight as you possibly can. Normally we rent rollers to basically go over it and compact it. You can actually see the roller bouncing. When the roller's bouncing, that's about as compacted as we can get it, okay? Another way to look at it is if you run the roller and you don't see it indentations, or it's seeing it shrink any or dip down or deflect into that rock, then it's about as compacted as it can be. I like to tell people about what I call the spoils rule, because what's going to happen is that when you excavate out this soil, depending on the volume that you've measured as far as length, and depth, what's going to happen is that soil is actually going to expand after excavation. It'll actually increase in size by about another 50%. So you have to have some place for that soil to go. I have some producers that actually sell the topsoil from some of these projects and use the proceeds of that sale to basically pay for the rock pads that they put in. Another thing, if you want to know, which I do, is how much rock do I actually need to add order, or how much do I need to get in order to do this particular project, depending on what you're planning. So what I do is I calculate, and normally this is in footage, but I calculate the length and the width in footage, and to get square footage, and then I multiply that times the depth that I'm going to go down, which is maybe around 0.8 of a foot, and so that'll give me the cubic feet that I'm dealing with. And then I divide cubic feet by 27 to get cubic yards. Then there's a conversion of about 1.5 to 1.6 to convert cubic yards into tons of rock needed to do the project. So if I do the calculations and it calculates out to be 125 tons, then I call up the rock company and I say, I need 125 tons. I'll probably need it tomorrow. Putting in essentially what we call a will call, which is essentially about 5 loads of rock, because you can get about 25 tons on a triaxle load. This slide is what you don't want to have when you get done. So what I can see here is a piece of fabric indicating the edge of the pad, but the rock actually extends out into the pasture. I want the rock over top of the fabric, and I want the fabric in the bottom of the hole. That's where it belongs. This is also the wrong size rock to be finishing up in, because cattle do not like to walk on this size rock. So again, you either want to put this rock in the bottom, and then you want to top dress it with about 3 inches, 4 inches of dense grade aggregate or crushed stone base. Then you can come on top of that with 1 inch or 2 of ag lime if you wish. But if a tractor goes clean off this pad and snags that fabric right there, then basically it's going to mess up this pad from here on out. I've listed basically the functions of the filter fabric. So it provides reinforcement and strength. So again, what you're getting by with is less rock when you use the fabric, but it has to be used properly, and you have to spread it out and no wrinkles, because what you're doing is you're essentially spreading out that load over a greater area. It's like if you have a mud pit, you drop down a sheet of plywood, you walk across it, you don't sink, because your foot pressures are being spread out over a greater area. That's what one of the processes of the fabric. So it distributes that load. And it also provides filtration and drainage, okay? When you're installing a road, there's 3 things you need to pay attention to: drainage, drainage, drainage. Okay, so by providing the filter fabric, especially the ones that actually allow the water to penetrate through, whether it's woven or non-woven, you get that filtration of that water and that drainage so that you don't weaken that pad. The other thing that you do with filter fabric is it separates the dirt below from the gravel above. Because what you're doing is essentially, without the filter fabric, you're combining 2 dissimilar products. And so like if you take 10 pounds of soil and you combine it with 10 pounds of rock, you're going to end up with 20 pounds of mud. Okay? So you have to use the proper filter fabric and use it in the right way. This is an illustration of tires, looking at the end profile of tires as far as the compressive forces that they apply to soils, depending on what the PSI is or the axle load on those tires. So you can see that the depth of compaction on here, you can see how much compaction is occurring. You can also see that this compaction is actually ballooning out, okay? And so that's another reason why this filter fabric is so important, because when that load spreads out like what you're seeing, that creates friction, okay? And if there is no friction essentially there, then basically it's going to spread out and it's going to make a wide rut. With the filter fabric, what you can get is the filter fabric actually provides friction with the rock sitting on it so it doesn't move, so you don't get this deflection of this load basically spreading out over the soil profile. The next couple of slides basically show concepts of how a livestock producer can use these all-weather surfaces to basically create control points where you can feed animals where they don't sink in the mud. So this is basically a line of ring feeders, hay feeders, that are set up on a heavy traffic pad using geotextile fabric and rock so the cattle can be fed, but they don't sink in the mud. This slide is showing a graphic of how these pads can be set up. In this situation, I need to change these numbers, but it's showing a distance between the rings of 18 feet. It actually needs to be 20 feet. You need around 8 feet per animal, so 8 and 8 is 16, and you need about another 4 feet in between to basically allow a pregnant cow to pass without pushing against her. So 20 feet in between the rings. The filter fabric normally comes in 15-foot widths. This is showing. And so like if you overlap by 1.5 feet at 15 feet, then basically you're looking at a pad width of around 27 feet wide, that'll work, okay? This slide shows basically how you can do that same line of ring feeders, but if you have a down slope that's actually going down to a creek, what you can do is create a little fenced off area, this is showing, where basically you exclude cattle out of that area and you allow that vegetation to get thick and lush so that it actually captures the runoff coming off that filter pad. So it captures the sediment from the manure, it captures the nutrients, and allows you can get a productive growth out of that particular area. And then essentially what you do is you open up the gate and you allow the cattle to go in there and flash graze it, and then but don't take it down to the nubs. You want to kick them out when it gets down to no less than 4 inches, because the idea is you want that thick layer of vegetation to filter out that sediment and those nutrients and pathogens before it gets down to the water body below. And this also prevents or keeps the producer from having to fence off the entire creek, which might be cost prohibitive, but you're just taking care of this one particular area because this is where the cattle are being controlled. This slide is showing a different graphic of how the fence line feeders are incorporated, because in the other 2 examples, basically you have to go into the field to feed the cattle. My question is why do you need to go in the field? You can just come in right off the farm road, you come in on the fence line, you can install what we call fence line feeders, which we have a publication on, and in this case it's just 2 roll bales apiece because of the site or the summit position that these were placed on. But you can put these things in you can make them 2 deep, 3 deep, 4 deep possibly. We have other structures that have 5 or 6 roll bales in them, but this is just the concept of how these heavy traffic pads can be used to feed cattle. The next 2 slides basically show a fence line feeder system that's installed on a ridge. This is up at the Eden Shale Farm in Owenston, Kentucky. And again, it's just showing you the versatility of these all-weather pads. Another use for geotextile fabric and rock pads is actually creating alleyways and trails for cattle to move or livestock to move from one pasture to another. I like these a lot. They're very good. And you can also install a waterer on these areas too, and so you can make that lane multifaceted, because not only is it moving cattle, not only is it not creating mud, but it's also used to create a watering point for cattle and to facilitate rotational grazing. This slide is showing a ground shot of an actual alleyway and trail that's installed on a ridge line that's running down between these pastures. And again, you can see that water that's serving multiple pastures the way this is set up. Not only does that water water those pastures, or the livestock that's in those pastures, but you can also use it to actually graze this lane as well, and there's no sense in mowing it when cattle can graze it. This slide is showing a four-way that was installed at the Eden Shale Farm in Owenston, Kentucky. It's a tire water that serves 4 different pastures, which is why we call it the four-way. So that facilitates rotational grazing. The area is large enough, or we made it large enough, because we, instead of putting one water in each field, we have one water that serves 4, so we can actually apply more funds to this particular structure, which, in making it bigger, which makes it more multifaceted, because we can put in this particular location, we can put in concentrated diets in portable bunkers. We can put in our mineral. We can put in a hay feeder in here if we want. The livestock that are in these fields, they can either use the whole structure or they can use half of it, depending on if we have the gates open or closed. You can also put an insecticide rope across the gateway opening to control face flies if you need to do that too. But again, you're making one structure, or what should be one structure, a watering point, into a multifaceted thing where it's also doing concentrated diets, minerals, lounging area, visiting area, social area, controlling insects, so on and so forth. So, something to think about. The next couple of slides show a barn floor that has a clay matrix to it. And it's one of the sticky types of clay that actually goes plastic when you get it wet like this with foot traffic. And so it was more like walking across lava, which could be a problem for cattle to traverse across. I mean, there's definitely, you could sprain an ankle or cause lameness with this type of flooring. So this clay was removed. We got down to a compactable layer of clay after that. After we removed it, we put down geotextile fabric. We put down the dense grade aggregate. We actually came back and put in this plastic grid, which you can see, which is now, I believe it's going to be cost shared here shortly. But that plastic grid, they actually run tanks across that, and fire trucks and other types of equipment. So it's an interlocking grid. It's like a that we put in, and then we backfilled it in with Class I sand, tamped it all down, and then we subdivided this barn into multiple pens to facilitate calving. And so you can see in one of the other pictures that we have in here, basically a cow-calf pair standing on this dry bedding. And so when you look at surfaces that animals want to walk on, I mean, ideally they want to be on grass, thick, lush grass. But they also, when calving, they want to be on a dry area. Like this calf wants to be dry, and that's good for its health. And then once you do the ear tags and make sure it's taking to the cow, it can go out into a field and be off this pad. So that's great. But again, different types of surfaces used to facilitate the production of livestock.